Okay, let's get started. Hi, everyone. Hey, don't fall asleep yet. I know lunch is coming soon, but we have one more session until then. So let's see where we can take the centralized logging topic together. So oftentimes you start developing your applications and you run Gradle or Maven or whatever, and it's working fine, and then you put everything on a test system and you try to look at the logs and it's still okay, like maybe you use cat to look at your logs. And then you get a bit more advanced and then you might use tailf to just follow whatever is happening right now. And later on you might say like, this is all fine, because tailf kind of works and I see what is happening in my logs. And we assume everything is fine, and then you try to put everything into production. And when you put it into production, it might look something like this. Then suddenly you don't have one window, but you might have three. And then you might scale up your application, and you might have the same application running not 3 times, but let's say a couple of times. And then tailf is not so great anymore, because you don't really see what is happening where anymore. And you need to find out like in which server or container or pod your logs are. So stuff is kind of getting a bit trickier and more complicated. And then you often figure out like, well, nothing is fine anymore, everything is on fire and everything is terrible. And we kind of want to avoid this terrible part of everything being on fire. And we want to log all the things, and oftentimes you do that and it's working well, but then you run into another problem. And that other problem might be that you have this very large log file and you try to figure out what is going on in my very large log file. So you're the little submarine and then you're just grabbing or parsing through a log file. And luckily, it's too dark, so I don't have to ask who is doing that because I wouldn't see it. But you can think for yourself who is using that and fighting like the log size and problems around that. So why am I talking about that? I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. I travel mostly around to show what we have and what you can do with our stack, and today is no exception. So I assume most of you are familiar with the infamous ELK stack, Elasticsearch, Logstash, Kibana. So Elasticsearch is storing the data, Logstash is getting the data, parsing it, enriching it, and Kibana can visualize it. When I say parse, what do I mean when I say parse? Any guesses? What do I parse with my log files? Normally, you might have like one log line, and then you want to parse out like the timestamp and the log level. So you could easily filter down on one specific log level afterwards. So maybe you're only interested in the exceptions or the errors or severe messages. What would I mean when I say enrichment of your logs? What would make your logs rich or enriched? Any guesses for that? So enrichment would often be like you have some additional metadata and you want to add that metadata to your log. So for example, if you have an IP address, you might want to get the GeoIP and do the GeoIP lookup on that IP address. So you can say like, okay, this request is coming from Poland and probably somewhere around Krakow, depending on how good that information is. But it would also be like information like metadata for Kubernetes or Docker. So you might know like which namespace is this, what pod, which host is this running on, or what is the base image from this entire application. Just you get an idea of what you have, not just the raw log line, but a bit more context around it to figure out like where is this coming from and what does it even mean. And it's not just an independent log line, but it has some more metadata around it and attached to it. And then we added at some later point, we added beats. So ELK is nice, but Logstash is sometimes a bit heavy. It's a tool that can achieve a lot of stuff, but it's not always needed. And we wanted to have a more lightweight shipper, and that's Beats. Since that is written in Go and you get native binaries, it's basically, I always say it's a bit like tailf, but over the network and on steroids. Because it can just tail a file and forward that file, and you can parse and enrich it somewhere else and store it somewhere else. You just want to get it off the host or off the container or of the Kubernetes cluster to get into your logs. The main problem is there is no B in ELK. And that's why we tried to come up with this one. That's, you can see it's the ELK B or BELK. It's a B and it has ELK horns, so it's kind of the combination of the two. But since we're always about scaling, this is not overly scalable. Because what happens if we get another product? For example, we have APM for tracing now. What would happen if we wanted to add APM to that thing? and then we would need to add another letter and need to make up another animal, and it's not getting easier finding and creating these animals. So we kind of stopped that route, and now we just call it the elastic stack because that's super scalable. Whatever fits into that one, like we might have to redraw some of these squares, but otherwise we don't have to rebrand every time we add another product or category to that thing. So if you say elk, we will understand. We even have elk logo still, and we used to have a plush elk, but we generally try to call it elastic stack nowadays because that's slightly more scalable. So if you have your application, normally you will use beats to collect your data and just forward it, and then you can either put it into Logstash, and Logstash can do the parsing and enrichment, and then store it in Elasticsearch, and then Kibana can visualize it. Or beats could talk directly to Logstash if you don't need any additional or heavy parsing there from Logstash. So you could just combine that either way. And today I want to show you a couple of patterns. I will use our stack as an example, but most of these patterns are very widely applicable, and you will run into the same issues pretty much with any logging solutions or any centralized logging solution. So we'll see where we can take this. So we're using a Hello World application. This is not a proper application. Your application will be more complex than this, but for the examples, this will be fair enough, and it will work and show you what is going on in there. So I'm using Logback, and well, I hope that's your thing. Otherwise, you can do the same with Log4j too, and it doesn't really matter, but I'll use Logback. I'll use SLF4j as my logging facade, so I'll talk, my Java application talks to SLF4j. For logging, my logging backend is Logback, and I will use MDC for structured logging. What does MDC stand for again? Anybody remembers? Yeah, map diagnostic context. So basically it's structured information you want to add to your logs. And that structured information could be something like, for example, a user has logged into your system, and afterwards the user complains and says like, your system is slow, or I ran into issues in your system. And then you could just pull up the logs just for that specific user. So the idea with MDC is it's not just raw logs, but you have some additional meta information again that you can add from your application, and then drill down into the right tooling or the right log events easier that way. It could also be, for example, you have some specific session or some specific business use case, and you just want to tag your log events and say like, I'm only interested in this kind of information, and I can get to that by applying the right logs for that. And I'm having the Logstash appender as my library to help me with some tooling around that, but we'll see that in the rest of the talk. By the way, if you're using any other programming language, not even in PHP do you have the problem of not having a proper log appender anymore. So any other language, there are proper log appenders to do very similar things to what I'm doing. I'll just show you Java examples today. But the concepts translate to any other programming language. Even PHP or JavaScript can do the same thing. Two things before we dive into logging that we don't want to do. First off, we're not using println for logging, right? Otherwise, we can discuss that afterwards, but we will assume we want to have proper log levels, and we want to be able to tune log levels up and down and probably filter based on specific classes or whatever. So we don't want to use print for logging. And the other thing is, we don't want to have too much coupling. So what we don't want to have is that my Java application needs to know so much about my logging backend. Because why should it? What I want to generally avoid is that when I change something in my centralized logging backend, I need to change something in my Java application as well. To various degrees, you will be successful or unsuccessful with that, and we can discuss that with every single pattern that I show you. But the general idea is you want to have your application as independent as possible from your logging solution, because it's just unnecessary having them tightly coupled. So if you, for example, scale up your logging backend infrastructure, you don't want to redeploy your Java application just to configure where the logs should go. Like that should be more automated and on a different level. So you don't want to run into that one. So the first pattern I want to run in or look into is Parse. And let me start my application in the background. So this will take a minute or so until it's coming up. So I'm just using Docker Compose here. I'll show you the link to the code at the very end. So if you just want to try that out, you just do a git you just clone the repository and then do a Docker compose up. It will pull half the internet for Docker images, and then it will run some applications. So while this is coming up, I'll quickly show you what I have configured here in the background. So we have a Docker compose file, and we have multiple, so I have Elasticsearch running once, so I can put my log somewhere. I have Kibana running, so I can look into what we have collected. Then we have multiple other components, like we have one Logstash instance for the parsing and enrichment. We'll have FileBeat to ship the logs off to Logstash, and then Logstash can forward it to Elasticsearch, but we'll get into that one in a moment, and then we'll have some other file beats. We'll also have my Java application. So what I have here is just my regular Java application that runs. And while everything starts up, let's look into the Java application. So I have not much going on here. I have a loop going from 1 to 20, and then I just log out a couple of events. So I'm using structured events. I have a session, and the session is just a random number between 0 and 99. This would be like your user. For example, in a proper system, you would have a proper user logged into your system. But here I'll just generate this random session to see how the user is doing. And then I'll also keep track of the loop. So I'll put my current loop iteration into that. And those are my two structured pieces of information I put or add to my log event. Then I add one trace statement where I actually log out the iteration and the session explicitly as well. Then I have here this pattern where something can be divided by 15, you will have a runtime exception, by 5, a warn, by 3 an info, and otherwise a debug. What pattern do I have here? Has anybody done interviews recently? Because that's kind of a common question. FizzBuzz, where you can, depending on if the number can be divided by 5 or 3 or 15 or whatever, it will say fizz or buzz. And I've kind of built the same thing for logging. This is not like helping you in any way to do a proper application, but for a Hello World application, this is just logging fine and giving you some outputs here. What is this? Looks kind of weird. Any guesses? Yes, that's an emoji. Because you need emojis everywhere nowadays, and we'll see how throughout the entire logging stack you can use emojis, and we'll figure out which emoji that is afterwards. So, on a more serious note, so I have my loop iteration here, and I have these log statements. How many log events should we get in total? Who is for 19? Who is for 20? Anybody for 38? 40. Anybody for more? Well, hopefully 40. So we have a loop going from 1 to 20 inclusive, so this should be 20 runs, and then we'll have 20 trace statements, and then we'll have 20 others which are one of these here. So we should have 40 log statements in total. And while I have been talking, my entire stack has come up in the background, and Java application also ran once. So hopefully, let's see if the demo gods are with us today. Let's see if everything came up already and if my logs have been caught. So I don't want to send statistics, but let's look what we have. So we are in the Parse index. So this one is the Parse index. We'll get to the others in a moment. What is kind of surprising is how many log events should we have? 40. Now we have 42. I mean, 42 is generally always the right number, but not today. Any guesses what could have gone wrong here? Why do we have more log events? Let's make this slightly larger so you can see it. So you can see we ran our application, we just started it right here, and we have 42 log events. And now you can unfold one here, and you can see whatever happened in here. And you can see here, this was a trace statement, and this was the log event. And I have extracted here the trace statement. We'll get to that in a moment. We'll have the labels where we have sessions and loops. So here we also have extracted the loop explicitly, so you can filter down on all of those. So that's all nice and working. Now the question is, why do we have 42 events instead of 40? Let's toggle this column here and look at the trace statement, or like look at the log levels. So if I look at those, you can see here we have a trace statement and we have various others. But 2 don't have a log level. And if I look at those, what do I have here? That's my runtime exception, and that's one line of my stack trace. Is one line of a stack trace very helpful? Generally not. One line of a stack trace doesn't make much sense. So how will we fix this? Do you think it's easier to take out the log lines of a stack trace, or the lines of a stack trace, and then combine them back together, or avoid breaking up the stack trace in the first place? So it's much easier not to break up the stack trace in the first place, because otherwise it's pretty much like if you have meat and you grind the meat into hashed meat like for a burger, it's trying to put like that original piece of meat back together. It might be possible, but it's not exactly an easy task you want to do. So generally what you don't want to do is you don't want to break up your stack traces. And if I look at my log, at my actual log event, you can see here, this one here was broken up into 3 lines. So this one is the arrow line that we had, and these were the 2 additional lines. And because of those, we had 42 log events now, which we didn't want to have. And we want to avoid breaking those up. Any guesses how I could avoid breaking up those, that stack trace? Yeah, log to JSON, that we'll get to that later. That would make our life much easier overall as well. But to avoid like breaking up the stack trace in the first place, I'm using this pattern where every new log event starts with a square bracket and then the date. So what you want to do is when you collect the log event, you basically want to say this is either a new line when it starts with a square bracket, or it doesn't have a square bracket in the beginning. Then it's kind of the continuation of the previous line, and you don't want to break it up, but combine it with the previous one. So what you want to do in the file beat that is collecting that one, you want to enable this rule here, which I have already added. So basically what you're saying is, if my log event starts with a square bracket, then it's a new event. Otherwise, it's a continuation of the previous one, and it should be combined. So anything that doesn't start with a square bracket will be put together with the previous ones. And that's working here. For example, here, we are just looking at those log events, like we're collecting everything in that log, and then we'll just say like, if it doesn't start with a square bracket, combine it. We could also exclude specific lines. For example, if you say, yes, we are writing out to the log file on trace level, but we don't want to centralize that because it's too much, you could exclude those lines. But I'll keep them, otherwise we would only be down to 20 log messages, and I'll want to keep that at 40. So what you can do then is we can just look at our containers that are running. We have our Java application here, and this is the ID. So I can just say docker restart and that ID. And then we'll restart the Java application, and hopefully, if I've done everything correctly, those rules will have reloaded in the background. And now that I'm running that, we should get another batch of events. So how many log events should we have in the parse index in total now? Hopefully 82. And luckily, yes, we do. We have 42 here, and now we have added 40 here, and those look correct. By the way, I talked about the emoji before, and that one is in the error statement, and you can see here, this is the emoji that we had here. So luckily, our entire stack supports emojis, so from collecting with beats, forwarding it to Logstash, and parsing it there, and then visualizing it in Kibana, everything supports the emoji. And you could even just filter down on everything that has the user experience with that emoji. You could just say user experience, because this will autocomplete and this knows what all the different states are. And then you would need to know, for example, my emoji is that swearing emoji. I think this one is the right one. And then you could see we have our 2 errors now, and we could just say like, I want to toggle this column as well. And then you can see this was the user experience, and you could just filter down on emojis as well. Important features for logging, so you might need them sooner or later. Okay, but you can see I have all that information nicely extracted. For example, I have a log.level, and it's error. Out of my log message that I had here, how did I extract the log level, just this single piece of information here? How do I get that out? I write a regular expression to parse that line out into the individual pieces. The way we do that is we have something called Grok, which is like named regular expressions to make it a bit easier. But in the end, you write regular expressions. Who likes writing regular expressions? That's generally the Stockholm syndrome, right? You got so used to writing regular expressions that now you start liking it at some point. So, how would you go about starting to write the right regular expressions to parse something? So we have a tool to make your life a bit easier. So let's head over. Here under that wrench, we have something called the Grok debugger. In the Grok debugger, you can just parse one log line that you have. For example, here you can see this one. And then you need to write the Grok pattern. The Grok patterns is sometimes a bit tricky to remember how they are called. So they are like named regular expressions. Let me just open the documentation to make it a bit easier. These are basically the patterns that you have. So rather than having to write like this regular expression, you can just reference it by saying username, and it will apply that pattern for you. So this is the point of Grok. It's a named regular expression. And for example, we have an entire section for dates and timestamps. And since I've done this a couple of times, I know that this one is the one for the way I wrote my timestamp, so we'll use that one. And now we need to write the regular expression. So those who raise their hand that they like writing regular expression, this is your chance now. What do we type to parse this log message? So we'll probably start with the line starts with that little roof icon. Then we have a square bracket, but we need to escape the square bracket. So we'll escape the square bracket. Then we need to add the Grok pattern. And the Grok pattern is a percentage sign, curly brace, the name of the Grok pattern, and after a colon, you can put the name of into which field you want to put that. So for example, I can call that log.level, and then I close this one. And when I simulate this one, you can see log.level, and it extracted the right timestamp. So this one worked. Then you will need to close the square bracket. Let's quickly do that. So we close the square bracket. What do I type then for the space? So there's one trick that will make your life a bit easier. You can just type space, and this will basically eat up any white space. So one or more spaces or one or more tabs will be eaten up by that. And since we don't put that into a specific field, so we don't put it into foo, it will basically be just thrown away. And then we could say like, this is, I think the right pattern here is word, and I want to, and by the way, this one is not the log level, this is timestamp. Nobody said anything. So this is the timestamp, and this is the log level. Let's try that again. And now you can see, okay, this was the log level, and now we have the timestamp which we have extracted. It's probably not so much fun seeing me write this entire regular expression to break up all the individual pieces, but if this is your thing, you can do it. I'll just cheat, and I have that in my configuration of Logstash already. So this is the right pattern. So like in every good cooking show, I have prepared something for you. We'll just use this one here, and this will also handle the stack trace correctly. So when I simulate that, it will extract the entire message, and this is what you get out. One thing that you still need to do is you can see here in the labels, we have those matched together. To break those out, we have something called a key value filter as well, and basically in the key value filter, here I say in the field log.labels, break up on the comma into different key value pairs, and then by default it will know everything with an equal sign that is like a key value pair, so we can break those out, and then it will have session equals 19 or session colon 19 in JSON explicitly. So this is how we can parse all of that. So we have seen all of those slides. Yes. Those of you who don't like writing regular expressions, I have good news for you as well. We have another tool that will make it a little easier to write your regular expressions. So we have something called AutoGrok. And basically what you do is, it's a visualizer. You can just upload some data, and I will just pick my log file. So I need to head over to my Java logging, and then here we have the .log file. I'll just upload that log file, and it will be analyzed, and it will then suggest some patterns how it could parse that file, or what kind of information it could extract. So you can see here I've imported 125 lines because I've been running the demo a couple of times, and down here you can see what it got out. So this is the Grok pattern that it guessed automatically. I didn't have to write that. This is like, it's not perfect, but it's a good starting point. So you can see this one got the timestamp right, for example, and the log level, and then the session it saw correctly, and then the user for the loop. So you can see these were the log levels that were extracted, that the loop counts, the session, and you can see 10 was by chance the most common session, and you can see these were all the timestamps and the messages, so this is what we extracted here. This will not be perfect, but this is a starting point, and you can take that, go to the Grok debugger, and then kind of like fine-tune it. So this will make your life a bit easier if you want to write regular expressions. So the good thing is you don't need to change anything. If you have your existing applications and you have a log file, you don't need to change anything. The downsides are you need to write regular expressions unless you like that. Be careful with multi-line statements, because if you break them up, they're pretty much useless. And you have some coupling, because every time your Java application changes the log format, you will need to change your log or your Grok patterns, because they always need to match up. So you have some coupling between the two, and it might be a bit annoying. For example, if you have multiple departments writing Java applications and they don't all use the same Grok pattern or the log formats, then you will have to write various different Grok patterns, and it might be a bit of a pain in the ass in the long run. So what alternatives could we use to writing or parsing log files? How could you also get log files without parsing? JSON, yes, that's only the third pattern I will go into. The other one will be, or the second one I want to look at, is sending directly. Is anybody doing that? So basically, your log appender sends the data directly to the centralized logging system. Anybody doing that? So it works kind of well. What you generally have is you have your log appender sending directly to Logstash, then Logstash putting it into Elasticsearch, and you don't need to parse anything. And in my logback configuration, this is basically all you need. What is the downside in this one? Or what is the apparent downside already here? Yeah, you have some coupling again. So everything works nicely, and we have encoding, and we don't really need to care about like how you write your log format. But here, you need to know where does Logstash live. So this is the Docker container, and this is the default port. And there it will be just accepting that. If you look at the configuration here, this is the TCP port 5601, that JSON log lines. This is kind of like the input that I get in here. So we don't need to do any parsing or anything, because this is just from the file beat. But you have this coupling between Logstash and your Java application, which you might not want. But the good thing is this just works. So if I head over, okay, now we just have one event. Let's say I get rid of all of that and I want to get all the events. Now I have 40 events. Is that how many events you were expecting? Or actually, let me make that 30 minutes to make this a bit more obvious. So here, sorry, we're still in the parse index. We need to go to the send index. But here, you see, here we had 42 events. Here we had 40. If I switch to the send index, how many events do you expect? Hopefully 80, because we ran the application twice, right? But when I hand over to the send index, you will only have 40 here. And this is already the biggest downside of this approach, because when we started the Java application, my Java application started up and was running and trying to log to the log appender before Logstash was even up. And generally, Logback will keep up to 200 megabytes of logs if it cannot reach the destination in a buffer. But if the application is starting up and it has never reached the destination, it will just throw away the log events. So here, when you start up the application, basically we lost the first run and we lost 40 log events. So besides the coupling, this is kind of the second downside. If the receiver is down, you might be missing out on those log events. And especially if something is not working well in your application or the network is down, that's normally when you're most interested in the logs. And exactly then is when you don't get anything in your logs. So that might be a bit of a tricky situation. But otherwise, this is working well. So if you look into the log events here, you can see this is a bit shorter, but it has everything nicely structured. So you can see this was the session, so even the MDC information is nicely structured. You have the class, you have the actual warn message, and investigate tomorrow was the message. So all of that worked well. We don't have the overall message with the long log line, because we didn't have one log line to parse apart. So this is all you have in this one. So you don't have files, and it's kind of more efficient because it's kind of stupid. In the previous example, my application had everything in a structured format, then it wrote it out to a log file, and then I tried to parse it back to get it back into the original format that my Java application already had. So we can just skip that by skipping writing out to the file, but then we have this problem of more what happens in the case of an outage, and we have a bit more coupling between my Java application and the log appender, which is not so nice. The next one is structure. This is the JSON approach that we have been talking about. So basically what I want to do is I want to log out to JSON, and this one might look slightly more complicated on the log appender. So this one here is the one for JSON. So I have a rolling file appender just with a regular file, so this will be rolled over every now and then, and we're writing out to a JSON file. And we can say that this is the pattern that I want to have here. So you can see we have a log level, the process ID, the thread, the logger, the MDC information, all of that is here. And then you can look at that one here, and you can see this is how we write it out. So it's just regular JSON and all nicely structured already. Once I got the comment that somebody said, like, this is not a proper JSON file because a JSON file would be just one JSON document, which is true, but we always write it out to one log line to have that here, and we'll collect all of those log events. How do we handle the stack trace with the multi-line statements? Do we need to do anything specific? Any guesses, or anybody tried it out already? So we just need to scroll to the right to find it, and here you can see this is my stack trace. So you can see here you just have \n for new line and \t for a tab, and this is how it's broken up. But it's still just a single line in the log event, so FileBeat is also not breaking up the log line, so you will not have problems with stack traces being broken up in a weird way. It will just be a very long line that you need to collect. And then I can head over to the parse, the structure index. How many logs events should we have in the structure index? Hopefully 80 this time. So now you can see it worked. We have 40 here and 40 here. You can see we have kind of the same information. Let's go to the error one again. So you can see we have parsed everything out nicely, or everything, actually we haven't parsed because it was structured in the first place. So this was all correct in the first place, and we have just collected the file. And for FileBeat, this is actually very simple. All we have to do is tell it, well, this is JSON, and we need to collect JSON correctly. So my beat is writing out to the JSON file, the FileBeat is tailing it, and it sends it directly to Elasticsearch because we don't need Logstash anymore. There's no parsing to be done in this example, so we can just skip Logstash here. This is what you need to configure in FileBeat. So in the regular log file, you would just have this section, but now I replace .log with .json, and then I have this configuration here saying, well, there is a JSON message under message, and just put this as the root element into your log file afterwards, or into Elasticsearch. And this is all you need to do to collect the JSON file correctly and store it centrally. Another very nice feature that is kind of hard to show in my example, but here we have something called a stack hash. And the stack hash is a hash of the stack trace. So basically we have taken the stack, the error message, this one here, and hashed it. And you can actually throw out everything that changes between runs. So for example, if you have some reflection that might be different every time you run this code, you can just ignore that. But otherwise, this will be stable and uniquely identify one specific stack trace. And with this hash here, you will know how many unique stack traces does your system have, when did they happen, and how many times did they happen. So you could see like which stack traces you should try to fix first. And you could even visualize that. Since I only have a single stack trace, it will not be super like impressive, but we could just say like, I want to have like a horizontal bar chart from the structure index. And then, for example, you could say the x-axis that I want to have here is a term. And the term I want to break this up on is stack hash. And when you run that, you would see the top 5 stack hashes. But you can see in the last 30 minutes, we only had a single stack hash. And this is the single one that we had. Where do I calculate that hash? That's a feature of the log appender, actually. This is not what we do in our stack, but this is being done by the log appender. So you don't have to worry about that. It's just a feature you need to add to logback. The good thing is it's kind of the right format because Elasticsearch stores JSON as well. So you have JSON, you're done. You might have some JSON serialization overhead. And some people say like they find it hard to read the JSON log message rather than the regular log message. But I think you could get used to that. So I feel like this is kind of the one approach that we would generally recommend if you can. OK. So if you containerize, I assume most of you are using Docker for that anyway. So if you use containers, where do you throw your logs? Yes, system out. Because otherwise, since my Java application was containerized in the first example, what I had to do basically when I was logging that, let me quickly show you, here in Docker Compose, basically my Java application, here I had to mount out the log file. This is where my Java application is logging. And I took that log file and put it on my host system in that bind-mounted folder. And then we have filebeat for Logstash. This one was mounting that folder again read-only. So basically, out of your Java application, you write the log file. Then you need to mount it to the host. And from the host, you need to mount it to the sidecar or filebeat that we have running here. And that's kind of like very statically configured and not what you want to have. So system out is a much easier approach. So basically what you do is, in your application, you just write to system out. Then it will land in the default Docker JSON logs that Docker is writing to disk. And then we can just run filebeat once as a sidecar and tail those log files. And you don't need to wire every container statically to some other folder and try to collect that. You just write to system out, and you don't have any other coupling from your Java application to the logging system because we can just in the background collect that, those folders. So what we need to do then is in your filebeat Elasticsearch, no, filebeat Docker configuration, what I do is here, actually I say, this is a Docker log. And it will know where the default Docker log lives on your host and will collect it. But I'm running this filebeat in a container. So how does that container get to the logs on the host? That one you again need to mount. So what I'm doing here in my Docker Compose file, if I had filebeat for Docker for Elasticsearch, what you need to do is, if I see the right one, yeah, you need to bind mount the right directory. And this was the wrong, wherever my configuration here is. Yeah. It's getting the right volumes. So I think I even have that here. So the idea is generally you run it in a sidecar, and from the sidecar you collect those. So you just tail those log files from the beat, and then you're good. If you want to see a sample configuration, we have that as parts of the beat repository as well. But I will show you how to do that. So what you do is you enable those hints, and then you just need to bind mount the right folder into that. And then you can also get Docker metadata. So let's see what we actually have in there. So if I head over to Discover again, and I head over to Docker, how many log lines or log events do you expect? Yeah, you will be all very wrong. Yes, we have 1,200. Why do we have 1,200? Because I didn't specify I just want to collect from one specific container, but from all the containers that I have running. But now we have Docker metadata, and now we can filter down on that Docker metadata. So for example, we could say container.image name equals, and it will suggest like these are all the ones that I have. And you can see, for example, I built the Java logging 100. This is my current application that I have. And I'm just interested in that image. So I can filter down on that and ignore all the other containers that I have running. And when I filter down on that one, it should just give me back my 80 log events. But this one is 81. Any guess why 81? Because the very first one that we have started, this one here, this is some information from the log appender itself. So if you see here, logback had one message itself when it started up, and we collected that. This is just the logback logging output itself, and otherwise we have the 80 events and all of those work as expected. So here you can see I have collected that information that we've seen before, like labels and errors and user experience and everything else, but we also have a lot of Docker information. So for example, we know the hash of the container, and we know what the project name was, and this is a production image, and you can see that this was the Docker Compose project. And we have all of those informations just from the metadata. So basically what the file beat does is it sees the ID in the path to the log file, it takes that ID and queries the Docker socket and asks the Docker socket, like, give me all the metadata you have for that specific container. And I add that to those logs. Also, one thing that is very nice here, so this is the output that you get. Sometimes you miss the very last line because Docker logs don't always add a new line at the very last line, whereas logback does that. And then we wait for a new line until we collect the line, because otherwise we're never sure if the line is finished or if something will come after that. So sometimes you might miss one line in a log event. What is very nice here is that we have a system called hints. And this is basically inverting like who is configuring how the logging system should work. And what hints do is we have this namespace .co-elastic.logs, and here that multi-line statement that you have seen before, you can add that here and you basically bake those labels into the container. So then you don't configure in your configuration like how the logging should work, but in your container you bake in the rule how this should be collected. And normally whenever you create the image, you know what the log patterns look like. So whenever you change it in your application, you just change the baked in labels here and you don't have any external coupling anymore. And then FileBeat will see that namespace and pick up those configurations automatically. So you don't have to instrument it any other way. And then you're done with the logging here. One other thing you should keep in mind is when the container runs, it keeps track of where you are in each file. And that is the so-called registry file. And that is basically like the file and the offset in the file. What happens if you update the FileBeat sidecar and restart it? The problem is then you would start collecting all the logs from the very first line, and you would duplicate probably a lot of the log events that you have collected in the past. Because the FileBeat container has been replaced, it starts up again, and it doesn't know where it took off or the previous one left off. So you should keep that registry file outside of the container, so when you replace the container, it can still reuse that registry file, and you don't have duplicate log events. You can also use, for example, patterns when you say, like, I want to put my logs to one specific index. If it's the Java application, I want to put it in the Docker Java index name and not with the regular application or the other applications. So you could filter here and influence where it should go and break that down. And then I have an ingest pipeline to parse that, but that's probably a bit too much for today. What you can also run into is some applications try to be fun, like Redis. They have this ASCII art when they start up. Is ASCII art very helpful when you do centralized logging? Probably not so much. So what you can do is you can define a rule where you basically say, like, this should be removed automatically. So basically what we see here is we use the Docker metadata, Docker container image Redis. So if it's a Redis instance, then we will apply this exclude lines rules, and this is the right regular expression to get rid of the ASCII art. And this way you can just filter out any ASCII art you have in there. And finally, who logs the logger? Because the FileBeat is writing to system out itself and then trying to collect its own logs. What happens if you have an error in that? Then you basically have a logging loop, like the FileBeat that should ship the logs to Elasticsearch has an error and cannot ship them off, but writes another log event, and then it tries to collect that and run it into another error. And you would have a logging loop, and you want to avoid that. So what I'm doing here is I'm saying logging two files true, so basically my FileBeat will log to a different log file on the file system to avoid having that logging loop with system out. Otherwise, you might be stuck on more and more events accumulating and you cannot break out of it. So it's kind of the hot stuff, but it's also a bit more complex than the others, so know what you want. Anybody using Kubernetes? Pretty much a lot of the same things apply from what you do with regular containers. Where do you put your FileBeat? Generally a daemon set. So you have exactly one instance running on every single node that you have, and that will collect your log files there. we have the configuration files for that in the Beat repository as well, so you can simply use that. You can get the metadata of Kubernetes, and it's either this block or this block. It's an XOR. So if FileBeat is running as part of the Kubernetes cluster, you can just say in cluster because it knows where the Kubernetes API is. If you install FileBeat on the host, you would need to tell it where does Kubernetes, like where is the admin API, so you can fetch the metadata from there. But that way you can still get the metadata from Kubernetes. And what you would then get in your logs, you would see something like, this is the pod where this is running, this is the node, the namespace. So you have all of that metadata, and you could filter down on that. So for example, if you have the namespace for one specific application, you could just see the logs for that specific namespace and filter down on those. There's more metadata we could add, but this is also a bit too much for today, but you could add lots of other kinds of metadata. To get rid of the ASCII art, here again, it's a very similar example. We're using the Kubernetes namespace this time. If that one is Redis, then we assume there could be this ASCII art, and this is what we tried to get rid of in our logs. You could even say, like, I have different namespaces for different applications, and I want to use one specific index for one namespace. This is slightly confusing here. So what you're doing is, if there is a Kubernetes namespace, use this one. Otherwise, fall back to FileBeat, then add the Beat version, and then add the date, for example. So this is the pattern you could use for indices and break up on namespaces. If you have namespaces, otherwise fall back to FileBeat. Even hotter, but even slightly more complex. So we're almost out of time, so it's time to wrap up. If you want to try out the examples, all you have to do is clone that repository, run a Docker Compose up, and it will do everything that I've shown you today. And you just have like the building blocks. It's, like I said, a hello world application, but it's a good starting point to look into the different approaches and what their downsides are. So we've seen parse, send, structure, containerize, and orchestrate, and what you can do around those. So those are the 5 patterns we have looked into today. So I think we have like 1 or 2 minutes left for questions. And I have to run off afterwards, unfortunately, because I have a lunch talk right after this one. But if you have more questions, just come to our booth on the first floor, like kind of like looking to the outside or over the entrance, and we're happy to answer your stuff there. Any questions for now? And I can barely see anything. Anybody got any questions?
I got a question.
Yes.
You pointed out the problem that the last line isn't parsed. Is there a way to force Beats into looking into it somehow?
So the question was, if you don't have a new line at the very last line in your log events, is there a way to force it to collect that line? And the answer is right now, no. So what Beat is just built to wait for a new line at the very end. Otherwise, it's not consuming that log event. And you will stumble upon that in the Discuss forums we have every now and then that somebody runs into that problem. But this is kind of like an assumption that is built in very deeply into Beats. Otherwise, we're never sure, is the line complete, or maybe the logger will add something to that still. So we kind of rely on the good behavior from the log appender to have that new line at the end. And we don't have currently a way around that. Yeah, I think we're out of time. Enjoy lunch. Thanks a lot.